We want to find the domain of this function. It's an arc cosecant, so think about the secant function and what the range of that secant function is. So let's just do a quick little sketch. We know that first we'll put the sine graph on here. So sine going to look like this, and we've got asymptotes anywhere that that sine was 0, and we can go ahead and draw our cosecant function. It's in between these asymptotes. And so looking at, and then it repeats, but looking at the range, then we see it goes up forever here, but it goes to 1, and here it starts at -1 and it goes to negative infinity. Notice this part of the graph right here, the cosecant never gets between -1 and 1. So we're going to have to look at two pieces here. First of all, this for the arc cosecant, then we can look at anything that is less than or equal to -1. So 8 plus x could be less than or equal to -1. Or we could look for the upper piece of the graph here, and that 8 plus x could be greater than or equal to 1. So looking at this first one, getting x by itself, we will subtract 8. And so it looks like we have x needs to be less than or equal to -9. The way we would do that as an interval would be from -infinity to -9. And then we need to put that interval together with the other interval we find from looking at the other piece of this. So when we subtract 8 from both sides, we have x is greater than or equal to -7. So the way we would write that is we would start at -7 and we would go greater. So our answer is the union of those two intervals. Looking at the inverse secant, then in the second one we're going to do the same thing. Let's draw a sketch of what that inverse secant looks like. So first of all, I'm going to put a cosine graph on there, and then everywhere that that cosine is 0, we know we have an asymptote. And then let's go ahead and put those little function pieces in there. And so as we look to see what this one does, it does the same thing as far as the range goes. We have from 1 to infinity, or we have from -1 to -infinity. So first of all, we could have 6x be less than or equal to -1, or 6x be greater than or equal to 1. And if we divide by 6 on both of these, and we list them in interval notation, then this has to be, it looks like x has to be less than or equal to -1/6. So going from -infinity up to -1/6, and it can equal 1/6 because that would make the place where it actually equaled -1. And we're going to put that together with our 1/6 to infinity.